Problem 55, jump game. In this problem, we have an array of integers. Each integer represents maximum size of a jump you can make from this position. So if you're standing on this platform, you can jump 3 elements or less. So you can land either on this platform or anywhere before it. So from this position, you cannot jump at all. The question here is, if you start from the first position, can you ever reach the last element in the array? To solve this problem, let's make a very simple observation. If we can reach any element in the array, we can also reach any of the previous elements in this array. That's very easy to see by contradiction. Let's assume that this element is reachable, and let's say there exists an element which can never be reached. Because it can never be reached, you cannot jump into it. That's fine. But therefore, what you must be able to do is jump over it, because otherwise this element here to its right would never be reachable. But if you can jump over an element, you can always make your jump shorter and land right into this element. So that means it's a contradiction. That element was supposedly unreachable, but we've reached it. Okay, that means we've proved that if any element is reachable, every previous element is also reachable. Therefore, we can do the following. If we traverse this array from left to right, we could maintain a single variable called edge, which will basically represent the furthest position to the right, which can be reached using the elements that we've seen traversed so far, right? So if we are at this position right here, we have this edge, which is pointing to the rightmost position, which is reachable from these elements somehow. Okay, so we're going to implement this by initially, how should we implement this? Initially, probably we'll set edge to 0 because we know we can reach element 0 because the game starts there. Then we will iterate over this array. So we should, obviously, we should check position 0 because we should see how we're going to update edge by using the information that this contains 3. So we should start traversing the array from 0 and then go all the way till penultimate element. We will check the penultimate element to update and see where the edge can move from this element. But there is no need to examine the last element because whether it shifts the edge anywhere, that will not really affect the outcome of the problem, because we need to know whether we can reach this position. Does not matter whether we can reach any further than that. So at any given iteration, we should do 2 things. First is update edge, right? So we will look at the value at that location I and update edge, and then we should see whether we could continue to the position e plus 1. That will do by making sure that e plus 1 is less or equal to the edge. If that is not true, then we should break. Okay, let's try to implement this now. So we said we're going to create a variable edge, which we'll set initially to 0, then we'll traverse the array from 0 to so we're gonna we won't touch the last element. We'll stop at the penultimate element. And inside the loop, we're going to do 2 things. First is update edge. To update edge, we'll say edge equals, and it should equal the maximum of 2 elements, right? The first is edge itself, or if there is a better option, that means we're standing at the current position and from here we could jump maximum of nums I. So out of these two numbers, whichever is larger, that should be the new value of edge. And then we said we're going to do a second thing, which is check whether I plus 1 is still less or equal to edge. So if I plus 1 is accidentally larger than edge, that means the next element is unreachable. So we should break. Now, when we come out from this loop, whether via break or completion of the loop, we should check whether edge is greater or equal to nums length minus 1. So if it's greater or equal to, then we should return true. Let's try this now. Okay, the pretest passed. Submitting. Okay. So, yeah, I think we did it.